students, today we are talking about Python operators, that is the fifth one. So, we are starting with the Python operator, and in the numbers those are 7. You can see the list of the 7. These all 7 operators are considered into the operators in Python. The first one is the arithmetic operator, the next one is assignment, comparison, logical, identity, membership, and the last one is bitwise operators. We are starting with the first one, that is the arithmetic operators. Now, these operators are basically applied for numerical data types, because these are generally considered as a common mathematical operators, just like your plus, minus, multiply, division. These are taken under this heading of arithmetic operators. You can see that we have the list of the arithmetic operators, that is plus, addition, minus, multiply, division, modulus, exponentiation, and the last one is floor division. Now, quickly take a look example. Now, here in this example we have the two variables. You can see the data is 10 and 3, it is considered as integer. Now, in this integer you can see that we are performing the arithmetic operations by using these symbols. Since I have written this instruction inside this print statement, that means that whatever I am seeing, it must be visible on the output. Here it is x plus y, that is 10 plus 3, that is 13. Here 10 minus 3, that is 7. The 10 multiply with the 3 becomes 30. It is a multiplication. Similarly, here you will get the value in float. The division always gives you the value in a float data type. The next one is the modulus. Now, here what you are getting is the remainder of this one, that is 10 divided by 3, it is 1. Similarly, the last one is the 10 raised to power 3, that is 1000, and last one is the floor division. It is a purely integer data type in the form of division. That is why the answer for this is 3. Let us look at example through programming. Now, in this programming we have run the code, the same code which you have seen in the previous slide, and there you can see the addition 13, 7, 30, 3.33, 1, 10,000, and the last one is 3. So, these are the basically the common operators which will performed on simple integer or the float data types. You can say the numeric data type. The next operator in the sequence is assignment operators. Now, look at this word assign. That means we are assigning the values after performing some operation, that is known as the arithmetic assignment operators. Now, here you can see the first, that these operators are already covered under the heading of arithmetic, and these operators are basically, these whole operators are under the heading of bitwise operators, because we are talking of the AND, OR, XOR, left shift, right shift, these are always performed with the bits information. So, we will see under the heading of bitwise operators in details. Just look at that how we are going to put the variables in the assigning operators. Now, this is the example. In this, again the variable holds the 10 value, and look at the very first operation, x plus equal to 3. That means whatever the operation you want to perform, you should put that operation first. This is the operation followed by the assigning operator. This is the syntax, and before that it is the variable on which you are applying it with the change value, let us say 3. Now, look at this statement. It is saying that x plus equal to 3. The deduction of this meaning is it is x equal to x plus 3. That means the x plus 3 value will be assigned again to the same variable, that is x. So, here the x value is 10. Now, the 10 plus 3 becomes 13. This 13 value will automatically get stored under this x. That means, right now the x value is updated from 10 to 13 by using the assignment operator. Similarly, you can see x minus equal to 3. Now, here again the operation is x is equal to x minus 3. Now, x value is not 10, it is 13. That means 13 minus 3 is equal to 10. Now, the updated value is 3 after performing this, that is the subtraction assignment operator. Similarly, the rest of the examples here you can see at the last, this is x double star equal to 3. It can be deduced that x is equal to x raised to power 3. Now, look at the program which we have run in the version 3.7.9. Now, here you can see that the value of the x is 10. After the first operation, the value updated to 13, similarly next operation 10 and so on. At the last the value is 0 because 0 raised to power 3 is 0. Similarly, these are the bitwise operator, we will cover in details in the bitwise operation section. So, for the being, let us just look at the output of this program, and here you can see the output of the program, that x and equal to 3, it is deduced as x equal to x and 3. The x value is 10. So, AND is the operation between these two operands. So, the answer for this one is 10. Similarly, for the left shift wise and the right shift wise. Now, we are going for the comparison operator, just the name suggests it is used to compare the two values. So, we are comparing the two values and these are the operators. Here you can see equal, not equal, greater than, less than. Now, the last two are the combination by using this OR. Right now, I am not going to tell you what is this OR operator, just take it as right now we are talking of the comparison operator. So, we will just limit ourselves to the comparison operator. So, these are the list of the comparison operators and to compare between the two values. Now, how we are going to compare these values? Now, look at this one. Now, the x value is 10, y value is 15, x is equal to y, that means it is taking this statement for equal. X equal to y, that is 10, that is 10 is equal to 15. Now, here the important thing is, now whatever the comparisons you are doing, the values are always in the Boolean data type. Now, here you will get the answer either true or false. So, the answer for x equals to y, that is 10 is equal to y 15, that means it is false. Similarly, the x is not equal to y, it will regard this as true, because yes, the 10 is not equal to 15. Similarly, the 10 is greater than 15, 10 is less than 15, and the last two one is x is greater or equal to 15 or x less than equal to 15. Now, look at the operations. Now, you will get the answer for this as false. Similarly, in the next one is true. Now, look at the last one. Now, here the 10 is less than or equal to y, that means 10 is not equal to y, but 10 is less than y, that is why it is true. Now, we are talking for the fourth operator, that is the logical operators. Now, here we are talking of combining the conditional statements, that means we can combine more than one condition statements by using the logical operators. These are three in numbers, that is AND operator, OR operator, NOT operator. So, these three operators are for logical operations and it is used to combine more conditional operators. Now, look at the example here, that x comma y is equal to 10 comma 15, again the x value is 10, y value is 15, and we are performing the AND operation. Now, the AND operation holds the two conditions. The first condition is the x is greater than 5 and the second condition is y is equal to 15. So, The x is greater than 5, that is true. Similarly, the y is equal to 15, that is also true. Since it is connected by the AND operator, that means the both the inputs must be true, then only you will get the answer true. Otherwise, everything becomes false. Similarly, here the OR statement is there, that means at least one is true. The OR statement can be deduced as, that means at least one conditions must be true, then only you will get the answer true, otherwise false. Here the one condition, that is this condition, is true and this condition is false, but I have already said this is connected by OR operator, that means right now one condition is true. So, last answer for this one is true, because at least one condition is true. Similarly, the NOT operator, now here you can see, now look at this condition, x is less than or equal to y. The x is 10, the 10 is less than 15. This condition is true. So, in this condition, what you are saying, that this condition holds true, but it is connected with the NOT, that means the reciprocal of the true is false. So, you will get the answer false. Let us verify it. Now, here you can see the answer for this one is false, because this condition is true and the reciprocal of or the negation of this true condition is false. Next one is the identity operator. Now, here what we are seeing, that we are using this again for comparing the objects, but in some different sense. What sense? It is the same object with the same memory, that means we are checking the two identity. The very first identity is it is representing the same object. The next is it is the same memory allocation. That means whatever the data, whatever the numbers, whatever the data type you choose, the datas are always represented with some memory. So, it is going to check on the basis of these two things, whether the object is same. The second one is the allocation of that memory or the variable will be on the same memory or not. So, the two operators are under this heading, one is, the second one is not. Now, look at the example. Now, here you can see that we have created the three variables a, b, c. The a variable is a tuple data. Similarly, the next data is also a tuple and almost identical to a. That means, the a is almost identical to b and the third is c is equal to a. So, we have created these three variables and I think so the three variables have the data type tuple. Now, we are using the identity operator, that is the is operator, to find out whether the identity of a is c or not. Now, the a, it is apple and ball. Similarly, the c, that is also represented is equal to a, that is again apple and ball. This is same, that means the object is same. Now, the memory address is same or not, that is the second criteria for identification, and this holds true. Similarly, here you can see, now we are not using any identity operator, we are using just the equal operator you have seen in the comparison operator. Now, we are comparing a is equal to b. Now, here the answer is true, because a and b are the same, but when we are applying this a is b, now what is the answer? Is it true or false? Now, look at this condition. Now, a is b and the answer for this one is true. That means, both the variables hold the same memory address. So, this is how the identity operator works, and in the previous slide this is the example related to is not operators. Now, the same condition is there, but we have just replaced it with is not. So, a is not c, that means here this a and c is not c or not. Similarly, we are using not equal to, and the last one again we are using establishing it by using the identity operator, whether a is not B. So, you can see that conditions are all false. Next operator is membership operator. Now, in membership operators we have two operators, one is in, the second one is not in, and generally it is used to find out a particular object. Now, you are going to see that these objects are basically the small information which must be find out, we are going to find out under a sequence and with the help of membership operator. So, what here we are doing is we are searching for this object under this sequence by using these two operators. Now, look at the example. Here again we have created the three variables, all three variables are string data type, and we are trying to find out whether the doctor is available under this sequence or not. This A is a sequence which is represented by string. So, under this string we are representing this whole data, and we are comparing whether this doctor is available under this whole data or not. You can see it clearly that doctor is there, it is a part of this string. That means, for this doctor, the answer is true, because we are finding doctor in A. That means, we are finding the doctor in the A variable, that is apple a day keeps the doctor away. So, here we are taking this doctor and we are searching inside this string. Similarly, you can see in the next example what we are doing is, right now the doctor is represented in the lower case. Now, you are going to see that what is the effect of case sensitive language, because the doctor with the capital D is here, and in this string the capital D doctor is there. That means, it does not means that the small d doctor is also available inside the string, because small d and capital D represents two different identities. So, here the answer for this one is false. Similarly, the B in A, you can see now we are putting the variables and we are testing the variables. In previously you are directly trying to consult the given data under a variable. Now, we are looking for a variable in a variable. This B is a variable, in this the away is the information, and in A this whole sequence is the information. Now, we are thinking whether this away is under this whole string or not, and here you can see this away is there. So, you will get the answer true. The same the rest for the not in operators. Now, look at the output of the program. True, false, true. This false is because this small d doctor is not available, because the capital D doctor is available. That means, the Python is a case sensitive language, and you should keep this thing in your mind. Now, the last operator, that is the bitwise operator, and here what we are seeing that it is used to compare the binary numbers. You have studied about the decimal numbers, but what about this binary numbers? Now, first we are going to understand that this binary numbers means what, how we are going to convert a decimal scale into a binary scale, and after that we will see towards the various operators under this list. So, we are trying to understand what is the bit binary language. Now, here in binary language we have only two parts, or you can say the representation of the language is by zeros and ones. So, it is a binary language. So, how we are going to convert this thing into the binary language? Now, look at this one. We need to draw this table. At here you can see the 11 is the decimal number, and we need to convert this 11 into the binary language. Now, how we are going to convert it? Now, let us look at this one. Here the number by which we want to divide, because we want to convert into the binary, The binary has only 2 aspects, that is why it is dividing by 2, and we are dividing 11 by 2. So, you can see in 11 the answer is 5. So, this is the quotient and the remainder is this one. We have shifted the remainder towards the right hand side. Next, again we are further dividing this 5 with again the same number 2, the remainder is shifted towards the 1 and so on, until and unless we get 1 or 0. Now, here what we are saying, it is 1. Now, we just need to shift it towards the right, and by looking at this sequence not from the top, but from the bottom. That means, you need to see this sequence from the bottom, or you need to write the sequence from the bottom, that is 1 0 1 1. So, 1 0 1 1 is the conversation in the binary form for 11. Similarly, you can go for these example, that is 20 and 7. Now, here this 20 and 7, what is the answer? You need to answer it. So, this 1011 is represented in a byte. A byte is represented by 8 bits. That means, a byte is equal to 8 bits. So, here the representation of the 8 bits are from 0 to 7, because the computer takes from 0, not from 1. So, 0 to 7, and we have covered last 4 digits by 1011. So, this is how the 11 is stored under a byte. You can try with 20 and 7. These two things are also good if you are going to try for this 20 and 7. Now, how we are going to convert this thing from the binary to a number? Now, look at this one. This is the formula. That means, whatever the value you have, you should multiply with 2 raised to power this one. Now, here you can see this. Similarly, for this one, and it is 1 multiply with 2 raised to power 0 plus 1 multiply with 2 raised to power 1 plus 0 multiply with 2 raised to power 2 plus 1 into 2 raised to power 3. Now, its 0 becomes 0. Now, here the answer is 1, 2, and here it is 8. 8 plus 2 plus 1, that gives you the 11. So, it is a binary representation for 11. In the previous lecture, you have recorded this lecture, seen that 11 is converted into the binary form. Now, try to understand about the AND or XOR. Now, here you can see that until and unless the both conditions are true, you cannot get the answer 1. Similarly, for the OR, until and unless at least one condition is true, you will get 0. If the one condition is true, you will get the answer true, because in OR it is represented as at least one variable or at least one condition, but in the AND all conditions must be met in order to get the true, that is the 1. But in XOR case, what is happening, if one of the condition is true, you will get the answer true, but in the rest 2 cases you will get 0. Now, the last thing about this thing is, now we are trying to understand what is left shift and right shift, and we are shifting this number with 1. Now, this is the binary conversation of, this is the 16 plus 8 plus 0 plus 0 plus 1, that is 16 plus 8 24 and 25. So, it is a 25 number which is represented into a binary number, and we are trying to shift this by 1. On the left hand shift means you just need to shift this whole block towards this one, towards the left side. Similarly, for the right shift, you need to shift the block towards the right. In the left shift, you can see the empty spaces are created, you just need to fill it by 0. So, the number is getting updated from 25 to 2 raised to power 5, that is 32 plus 16 plus 2. So, what is the number? That is 32 plus 16, that is 48, and plus 2, that is 50. The number is updated from 25 to 50 in the left shift. Similarly, here you can say the number is reduced from 25 to, that is 8 plus, that is 4, that is 12. So, the number is reduced from 25 to 12 in the right shift by 1 bit. Here we are shifting by bits. So, that is all in this lecture. We have covered all the major 7 operators, and the last we have understand that how the number is converted into the binary number. With this, I will thank you all for listening me. Thank you.